Hello everyone, welcome to this video. In this video, we shall be studying about family of solutions of differential equations. So in the previous video, you saw that solutions are of two kinds. One is of that explicit solution, correct? The second one is of implicit solution, right? So these are the two in which in the first one, in the explicit solution, the solution is obtained only in terms of all the values of x, only in terms of the independent variable, whereas in implicit we have some relation between x and y such that one of its function gives us the explicit solution, right? So here, when we wanted to talk about the family of solutions of differential equation, let's first of all see this differential equation, which is the first order ordinary differential equation. Dy upon dx is equal to 2x, right? So when you integrate it, this is very easy to solve. You can shift this to the left hand side, you can shift this dx to the right hand side so that you obtain dy is equal to 2x dx, and then you can integrate on both sides to obtain y is equal to, here it would be 2, here it would be x square upon 2, correct? So you obtain y is equal to x square as its solution after on integration. So by simple integration you obtain x square as its solution. So we say this function f0, which is defined for all real values of x defined by x square, this is a solution of equation 1. Why? Because when you substitute it here, when your function is y is equal to x square, when you take its first derivative, you would get 2x, right? This is nothing but your differential equation. So it satisfies your differential equation, right? Similarly, you can also see that the function f1, which is defined for all real x, such that f1x is equal to x square plus 1. Now we have added 1 to it. To x square we have added 1, so that our function becomes x square plus 1. This is also a solution of our differential equation. Why? Because if you take y is equal to x square plus 1, when you differentiate it with respect to x, so this thing would become 2x, and when you differentiate a constant with respect to some variable, it is 0. So it is just 2y upon dx is equal to 2x, which is nothing but your differential equation. So it also satisfies your differential equation. In a similar manner, if we instead of 1 now take the value 2, we also have this to be the solution, correct? So that means this constant here does not play a significant role. Even if it is present or it is not present, it does not make any difference. Why? Because we know the derivative of a constant is 0, so it does not create much problem here. So can we say that this thing is true for any real number c which is there, so that whenever you define some function f of c, right, so you would have x square plus c, and this general thing x square plus c is also a solution of your equation 1, correct? So yes, this is also there. So you see, we started from here the solution of x square, and we now obtain a solution which is x square plus c. So this is also a solution. So this is basically the general solution here. This c, what is it? It is called the parameter or the arbitrary constant, right? And this equation is called the family of functions, and this is one parameter family of solutions, right? So here we see that this fcx, this is this equation gives you infinitely many solutions. Whenever you change the value of your c, you get a new solution, right? And each function here is basically the solution of this differential equation. Why? Because it satisfies your differential equation, right? And you see that we call this c as a parameter, and we call this function as one parameter family of solutions, correct? So now once you know these things, so we can write the solution as y is equal to x square plus c. Now one must be thinking that why in particular I am using this word family here, family of solutions. Does it have anything to relate with our families? The answer is yes. Why the name family is given here? It is because a family have some common characteristic between them. here also the solutions also have a common characteristic. In our case, the solution came out to be equal to y is equal to x square plus c, correct? So here the common characteristic is y is equal to x square. This thing is not changing whenever we are changing the value of c. Hence x square is the common characteristic here. Hence it comes under the label of family of solutions, correct? And so the next question here is, can we conclude that every first order ordinary differential equation has so-called one parameter family of solutions which contains all the solutions of the differential equation? The answer is no. This is not in general true. Why? Because some first order ordinary differential equations, they might not have a solution. For example, this equation, they have no real solutions, correct? So, and moreover, even if some first order ordinary differential equation have one parameter family of solutions, that does not mean that all the solutions are present within this family. It might also be there that there would be some extra solutions which are different from this family of solutions, correct? So this is not true in general that this one parameter family of solutions contain all the solutions. Correct? So I hope you understood this concept of one parameter family of solutions. Well, that is it for this video. Thank you for watching.